All right, this was the summative quiz over circles. Um, and there were 8 total sections that we covered, 7 within chapter 10. We covered 11.4 out of 11, which was primarily on circumference and arc length. And it was more or less a rough quiz for a lot of people. 25.3 out of 40 is about a 63%. Um, the median was more like a 70%. So basically, half people got a 70 and or above, and half got 70 or below. Um, it, there were some really good solid scores, 30 or above on a unit test. I think is would be 75% or above. Definitely pretty good. A lot of B's right here at 32. It's 80%. But then there was this huge area down here, which obviously had a vast range of people that understood about half the stuff to people that understood well below half the stuff. And in this environment, I really have no way of knowing why that would be the case. I don't know if that's due to people just not watching the lessons and doing the assignments, or if that's due to people who were seriously confused by the lessons and the theorems. If that was the case, um, I'm just baffled why people weren't trying to seek help. Obviously, the office hours, the way that we have set up, but then you could email questions, you could ask questions through Google Classroom. There's so many different ways of trying to get help on this material, and I just did not see that happening. So my assumption is people are just turning it off, starting their summer early, which really is too bad. And I do think the prices that you'll pay may not be immediate, but in a class a couple years down the road, it could put you in a really rough situation. When we talk about, where are you most concerned at the end of the semester, this definitely backs it up. Circles. Once again, I don't know if that's just a flat result of that people could not learn in this environment, because the lessons were really the same, other than we weren't able to ask live questions during class, which doesn't happen a ton anyway. Or if it's just a matter of I really wasn't given it the time that it needed. I really don't know. I have no way of knowing that when I'm only checking, one homework a week. Um, there were some questions that were missed more than others. Number 9 was only about 4% of you guys got that one right. I've never had this happen before on a non-bonus question. Uh, nobody, nobody got problem number 10 right. Now, when I looked over it, there were about 10 of you that were really close to getting it right, actually, which would have put it, right in line with either 9 or 20, which were the other most missed questions. Um, but yeah, I don't think I've ever had this happen before. I was like a little shocked to see that. And then the bonus, of course, um, only 9 people gave it a shot, so only one person got the right answer out of that. Here's what I did. I divided it into the problems we really don't need to look at very much, because we're in pretty good shape. The problems that we definitely need to look at, because they were really rough. The where half or more people were missing it. I went up to 55%. And then the ones that are kind of in that intermediary area where probably too many people missed it, but we can kind of talk about those maybe a little more briefly. And so I just kind of color coded the questions. So here's the answer for number 1. You just had to read the information and realize h wasn't 4, h was -4, right? And the radius wasn't 9, it was the square root of 9, which was 3. And if you did those two things, you were in good shape, and most of you guys did. 100% of you guys got the right equation, or the right center, I should say. Only about maybe 3 people missed the radius because either you squared it when you should have square rooted it, or you didn't do anything to it. Number 2 was kind of in that vague intermediary zone, but I could certainly show you what's going on here. What we wanted to do on this problem, I guess there's a couple different ways you could have done it, but when it told you that you have two tangent segments to the same circle, we immediately know because they're coming from the same point, they have to be congruent, which means that these two angles, an isosceles triangle, have to be congruent. And if this part of the circle is 220, this part would be 140, subtracting from 360, and then these angles based on theorem 1011 are half of the intercepted arc. Tangents and secants intercept half the arc, so this would be a 70 and a 70, and then that would give you a 40 here, and that would have been the answer you were looking for on that problem. Number 3 was, and you can see about 68% of you guys got that one right, so I mean, it's not bad, but it's a little below what we'd like. Number 3, you guys were pretty solid on. We just, I think, had to realize that angle TNE was an inscribed angle, and angle TAE was a central angle, but they were inscribed in the same arc. So I think if we multiplied TNE by 2, if we multiplied this one by 2, and then we could set it equal to this one, then you could solve for x. And once you solve for x, you can plug that value in. And I won't work this one out because most of you guys did pretty well on this one. It looks like 76% of you guys got it right. I think if you solve for x, you might get 5. X is equal to 5. TN, what were we looking for? TE, so TAE, yeah, yep. So it looks like actually two more of you would have gotten it right if you would have just taken that answer and plugged it in. You just got your value of x and assumed that was the end of the problem. So you just got to read the problem a little more carefully there. So number 4 was a bit of an issue. Anytime you have a diameter, you really want to know that that's giving you some information about the circle. In this case, it's dividing it into a couple semicircles. Also, it's an inscribed triangle, so pretty much flat out we know that we have ourselves a right angle here. Okay, and that diameter has to be the hypotenuse. That's theorem 10.9. And so now I have a right triangle, and I have the hypotenuse is 18, and you could, if you really needed to, you could use trigonometry here, where I'm looking for the measure of arc LO. I'm looking for this arc, and so I would love to know this angle down here. And so I mean, I could say that the sine of theta was equal to 8, which is the offset, over 16, which is the hypotenuse, right? So you could use trig if you really needed to, but knowing that if this is exactly half of the hypotenuse, we would then call that the short leg and the hypotenuse, and that only happens in a 30, 60, 90 triangle. So now we know that this angle is a 60 and this angle is a 30, and you can double the 30 to get to the arc since it's an inscribed angle. Like I said, it was below 55%, but not much. I mean, it looks like it was barely below 55%. So actually, quite a few of you guys, about almost 20, so 12 would have been, it's interesting because 12 out of 25 would have been just below 50. So I don't know why it's telling me 54.5%. Maybe only because 22 people answered it. That's probably why. 3 people must not have answered, but that's how you do that one. Number 5 was not an issue. I think most of you guys knew that h was -3 and k was 5. So the only possible answers would have been B or D, or F. And then you just use the distance formula or the equation of the circle with the points to figure out what the radius was. And the radius turned out to be 5. 5 squared is 25. So there's your answer, D. And oh yeah, 80%, pretty good, pretty solid. Notice that B and F, which had the right H and K values, were close. People just couldn't quite get to the radii out of those. Number 6 was a little bit in the middle. This was just one of those where you had to use, I think, theorem 1016, and the tangent segment squared is equal to the exterior part of the secant segment multiplied by the whole segment. And the nice thing about this is you get a perfect square. And the square root of 144 is 12. And so if you knew the theorem, this one actually worked out pretty easily. But there were about 8 people that didn't get that right based on not using the theorem correctly. So I'm not sure why 1 out of 3 people didn't have that one down. I mean, it was open note, but it goes back to, if you didn't get enough practice, you're probably not going to be able to get them right suddenly out of the blue. Number 7, this one we had to add the arcs and average them. So we would have taken our 2 arcs and added them together, divided by 2, and then it would have been equal to that middle angle. So there was some algebra involved, but most of you guys got the right answer on that one. In fact, 77, so almost 80% of you guys got that one right. Once again, 3 people did not answer that one. Number 8, people did pretty well on. We see the parallel chords, and we also see the congruent chords. So that means 2 things to us. First of all, it means that because of the congruent chords, I'm going to get congruent arcs. So this is 110 over here. And then because of the parallel chords, these 2 arcs have to be congruent to each other. So once I subtract the 110s from 360, I think I can just divide by 2. And what would we have left over there? 140 divided by 2. Yeah, so 70 degrees would be the answer we were looking for on that one. And oh yeah, everybody got that one right, so 100% great. Number 9 was an issue, and I think these selected responses are always a little bit trickier, but these types of problems also, I think, trip people up. You really got to pay attention to the inscribed angles and what arcs they're intersecting. So for example, this angle right here, this 80, right, is intersecting this entire arc. So 2 times 180, or 2 times 80, I should say, is 160. So now I could subtract 50 from 160. So now I know this is 110. Okay, but now that and also I know that opposite angles and inscribed quadrilaterals are supplementary. Now think about what that does. It also means that this angle, if I wanted to do this, I could just subtract now from 360 these 3 arcs I have. But this arc here has to be 200, right? 100 times 2. And so 200 minus 80 is 120. So I could have got that 120. So now, like this angle right here, U would be half of 120 plus 50. Or I could have said that half of angle I, which is intercepting this arc, I didn't get it, there we go, this arc right here, it would be half of 80 plus 110, so that's 190, and half of 190 is 85, 95, so that's a 95. And once you get your values, you just kind of go over here and say which ones are true. Is the measure of angle A over here equal to to 80? No. Opposite angles are not congruent. Opposite angles are supplementary. Is the measure of angle U up here equal to 80? Well, no, it's not. It's 85, what we found it to be. Consecutive angles are not necessarily congruent. In fact, usually they're not. Is the measure of angle I 110? That's this one down here, right? Well, we found it was 95, not 100. But the very next one said, is it 95? So I would definitely say yes on that. Is the angle of UA 110? Yes, we did find that right here. So that looks good. Is the measure of JI, arc JI, so from here to here, 200? Well, from I all the way up to U was 200. This was 200. But JI was just 120 by itself, so that was not true. And so there were only two of these that ended up being true. You can see that a whole lot of people did pick those correct, 16 here or 13 here. So those were the most correct responses. But a whole lot of people did not get those. And then a big chunk of folks thought that these two guys were true when they were not. So it's really just understanding inscribed angles and inscribed quadrilaterals theorems. 10.7 and 10.10, I think, are the ones you really should go back and look over if you're going to be able to do a problem like that. So 10 was the one that really nobody got right, and so I definitely will work this one out for you. It tells us we have a tangent segment, and so with a tangent segment, that instantly gives us a perpendicular relationship to the radius drawn to that point of tangency. So we get a right triangle. And I also know that because the radius OS is 15, the radius OR also has to be 15. And so I think I have 15 squared plus 3x squared equals 2x plus 15 squared. And so this is going to be 225 plus, and this is where some people may have made their mistake. 3x squared is not 3x squared, it's 9x squared. Yeah, you can't ignore the 3. It's being squared as well as the x. And then when I FOIL out the 2x plus 15 squared, I'm going to get a 4x squared. I'm going to get a 2x times 15, which is 30x, and another one of those, right? So a total of 60 x's, and then finally a 225 for the 15 squared there. So then we look here and we notice that I think the 225s cancel out. And because there's some x squareds left over, I better set it equal to 0. So I'm going to subtract the 4x squared over. I'm going to subtract the 60 over, and I end up with this guy right here. And this is actually an easy factorization. They both have a 5, and they both have an x, both terms. So all that's left here is an x, and all that's left here would be a 12. And so is x equal to 0? Is x equal to 12? Well, I don't think x can be equal to 0 because that would give me a couple 0 lengths, which is not possible. So it looks like x is equal to 12. Now, it said determine the length of SE, which is this piece right here. So if I take that 12 and throw it in there, 2 times 12 is 24, right? And so that's how you work that problem out. This is the one that nobody got right. Now, I do want to point out that a lot of people, relatively speaking, it looks like 9 people ended up with a 12. So all you had to do is plug that 12 in and double it, and you had the right answer. So about 40% of you guys almost got it right. But there were so many issues on this. The answers were scattered all over the place, and I imagine some people didn't use the tangent relationship and used the Pythagorean theorem, and some people made some algebra mistakes. They didn't know how to square things, and next year you're going to be in algebra 2, so that's going to be something you're going to want to clean up pretty quick. Because nobody got this one right, even though I don't necessarily understand. I'm not saying it was an easy problem, but I think it was definitely a fair problem. um, I went ahead and credited 2 points back as a scale. So everybody got a 2 point scale on campus on the quiz. All right, this guy, we had to complete the square, and the answer ended up being this guy, option 5. And it wasn't really an issue. It looks like 80% of you guys got it right. Quite a few people picked option 1 as a wrong answer, and you can see that they are very close to being the same, except instead of a 22, we were getting a 12. So that had to be some kind of an algebra mistake with what we were adding in to the other side. Maybe people added when they should have subtracted, or subtracted when they should have added, or something. I'm not sure, but it looks like an algebra mistake. Option 1 is pretty darn close. We just did something that didn't work out on the other side. Number 12. Oh, we want all the major arcs, and you would have thought this one would be pretty easy. I think the most important aspect of this problem is that it gives you a diameter. That's really the only way you know it. It tells you that KT is a diameter. That's the only way we know if things are going to be more or less than 180. So like um, TKA definitely goes past 180 right away. So that, that one's definitely going to be a major arc. On the other hand, KAT is just a semicircle, so that's not going to work. NKT, NK, look at that. So as soon as it goes from K all the way around to T, there's the semicircle, plus it went past that. So that's definitely going to work. Okay. ATN. So that's from A to T to N. Wow, that looks close, but it didn't tell us anything about A and N. We don't know if A and N is a semicircle or not. We don't know. It looks like it's not, but you can't make those kinds of assumptions. My guess is some people thought ATN was probably a major arc when we just don't know. We don't know if it's big enough to be a major arc. KL T is another semicircle right here, so that would not be a major arc. ATL is Atlanta, that's in Georgia, so that's not a major arc. Actually, it's, we don't know if it's a major arc. It doesn't look like it, but there's not enough information to know what it is. An ANK from A all the way down to N. Oops, I went the wrong way. From A down to N, then up to K. Yeah, that one is, because look, we got a full semicircle in there plus the extra part. So it looks like 3 of these were major arcs. Now I'm guessing a lot of people that missed this problem either accidentally added one that wasn't, or might have missed one of those. I bet a lot of you guys got pieces of this correct, but just not enough. All right. Um, yeah, look at that. 96, 96, 96. So 24 out of 25 people got those correct, but it looked like a whole bunch of people thought ATN was bigger than 180 when we just didn't have the evidence of that. 13 was probably tricky for some folks because it led to a quadratic. The formula for this particular type of problem tells us to multiply the segments of the chord. So these 2 pieces multiplied out have to be equal to these 2 pieces multiplied out. And so there's some algebra involved, and I imagine this is where some people may have gotten stuck. The top one would be 4x squared. I would get a 12x and a 3x, so 15x, and then plus 9. The bottom one would be 3x squared. The middle terms would be 18 and 1, so 19x, and then plus x. So quadratics we want to set equal to 0, so let's subtract these guys away. So I'm going to get x squared minus 4x plus 3 is equal to 0. And now I just, try to factor it, which it does factor pretty nicely for you. X minus 3x minus 1. So x is equal to 3, x is equal to 1. Now check this out. Both of those numbers, because there's no subtraction in any of these terms, both of those numbers only produce um, positive positive answers. So what this means is we have two different answers for this problem. If I plug a 1 in, I would get a 7 here and a 4 here, so that would be 28. I would get a 7 here and a 4 here, that would be 28. If I plug a 3 in, I would get a 6 here and a 15 here. So 6 times 15 would be 90. And then if I plugged the 3 in here, I'd get 9 and 10. 9 times 10 is 90. So the one, yep, they both work. It looks like most of you guys actually got those, but not enough. Only 60% actually picked them both. So maybe you just thought there was only one answer. Quadratics are going to give you two. A diameter, which we do have a diameter here because it goes through the center, that is perpendicular is a bisector. And so what that's going to do is it's going to make these two pieces equal to each other. So if you set those equal to each other and solve, it looks like we would get 3x minus 7 equals 2x plus 1. So x equals 8. And then, it wanted you to find the value of AI. So we plugged the 8 in. And what would that be? 24 minus 7. So 17. Here's my guess. My guess is some people stopped at 8 because this doesn't seem to be a very difficult problem to be in the yellow category. Well, it looks like only 2 people stopped at 8. So it looks like 3 people did the entire chord instead of just half the chord that was asked for. So I guess those were the 2 most common mistakes there. I'm not sure. Not sure about all of these answers. We'd have to look at the algebra to really know what's going on. What do we got here? Well, first of all, we got a problem we can't really see. There we go. So, what do we know about this? Well, OM is 27. So they just gave us the radius was 27. And then, of course, they told us that MT was 260 degrees, so that means that actually, that wouldn't be MT. We would need another point over there because that's a major arc. But the minor arc MT would be 100 degrees, right? 360 minus 260. So what do we know? Well, the area of the circle would be pi r squared, so 27 squared would be 729. The circumference of the circle would be 2 pi r, so 2 times 27 is 54, so 54 pi. And the arc of TM, well, the arc of TM here would be 100 over 360 times the circumference, which we already found was 54 pi. So I think if you multiply that out, you would end up with 15 pi. So I think these are your answers here. And let's see where people may have slipped up on this one. Well, everybody got the right area. That's great. And almost everybody got the right circumference. One person picked 27, so he didn't do 2 pi r, he just did pi r. Looks like the biggest issue was the arc length. It looked like a lot of people just used the given 260 to find arc TM, but TM is a minor arc, so it has to be less than 180. So this can't be arc TM based on how you name arcs. Major arcs have to have 3 letters. So that might have been what happened on 15. 16 was pretty good. I mean, it's, the big arc minus the little arc divided by 2. So 122 divided by, or minus 36 divided by 2 gave you 43. And not bad. I mean, not super. 7 people still missed it. So once again, you might want to go back and check theorem 1013. That's the one that tells you to do 122 minus 36 divided by 2 to get angle J. Number 17 was an issue. Here's what we got. We've got two congruent chords. The reason I know the chords are congruent is because of theorem 10(6), which tells me that if chords are equidistant from the center of a circle, they have to be congruent to each other. So that means this guy is 16. But then I also have these perpendicular segments from the center that are hitting them, which means it's cutting those chords in half. And so what that means is, this is an 8 here. And then it also tells me that the circumference of the circle, which is 2 pi r, is 20 pi. So if you cancel those pi's and divide by 2, the radius is 10. So this radius right here, that was 10. So this is, I just think, a 3, 4, 5 primitive. 5 times 2, 4 times 2, 3 times 2 would be 6. So I think that should be the answer for the length of x. So about half of you guys got that one right. Okay, one person was very confused, but hopefully now you're less confused. So in this one, gave us a couple points. There's a bonus problem on an early quiz that was very similar to that, and it said if this is the center, then you've got this other point on the circle M, and we want the tangent line going through that. So there'll be a line that just hits that one point, kind of like that, right? To write the equation of any line, you just need a point and a slope. So we definitely have a point. That's great. What's the slope? Well, we don't have another point to find the slope. So what we do is we find the slope of the radius, because we know the radius and that tangent have to be perpendicular. And so I use these 2 points to find the slope, and y minus y over x minus x. Just glancing at it here, looks like it would turn out to be 8 over -4, so -2. So the opposite reciprocal of -2 for the perpendicular slope would be +1/2. So it looks like it has to be either be A or B. And then you plug your point M in with that slope of 1/2, and you solve for the intercept. It turns out to be -19. Okay, so that's kind of how you do that problem. And two-thirds of you guys got it right. That's not bad. But looks like most of the people that missed it picked C. So what that means is you just found the slope of the radius, and then you didn't take the opposite. So you found, what you did is you basically found the equation of the radius, not the equation of the tangent line. You have to get that perpendicular slope. Is the mistake you made. Number 19 was theorem 1015, where you did the secant, the exterior part of the secant times the whole thing. That's equal to the exterior part of the secant times the whole thing. Well, I don't know what this is. Maybe call it x. So that would be 6 plus x, right? And so we would get 120 equals 36 plus 6x. Subtract the 36 and divide by 6, I think, is what would give you your answer on that one. And it turned out to be on this one 14. So not really any heavy math on this one, really just knowing the right theorem and how to set it up. And about 2/3 of you guys were able to do that. And 1/3 of you guys made some either algebra mistakes or just didn't use the correct theorem. Our last problem was definitely missed by quite a few people. And it didn't give you a picture, so as soon as it starts telling you, you have a circle with points L and S and U on them, then I would draw that picture, right? And then it says that point A is on that arc. So here's your arc LSU here. A is somewhere on that arc, okay? And then you can kind of start setting it up. Is angle LSU? That's what we're looking at. Inscribed angle LSU Okay, now so keep in mind that this is the arc that it's intercepting. Okay, is that 90 degrees? Well, if LU here is a semicircle, yes, but we don't know that. Is it 1/2 of LAU? Well, LAU turns out has the same endpoints as the arc. It's an inscribed angle too. These inscribed angles are both half this arc. So this is actually theorem 10.8, which says angles inscribed in the same arc have to be congruent to each other. So it's not half of, it's equal to. And so that's, that's the answer. Okay. By the way, as soon as you saw the LSU, I hope you realized that this had to be Mrs. Moore's problem because she went to LSU. She's a big LSU fan. So yeah, I mean, boy, 10 is not very. That's a lot of people that missed that. I think a lot of you guys must have thought it was a central angle, and that's why you were doing 1/2 of the, if it was 1/2 of the arc, but not 1/2 of the angle. And so I just don't think you realized you had two angles that were inscribed in the same arc. I think that's where you really need to draw the picture out to see it, okay? By the way, bonus was really just going back to 30, 60, 90 triangles more than anything. If you um, drew a altitude down, and that's gonna split things up a little bit for you. You're gonna get a 3 and a 3 here, and then half, it's equilateral, so you have all these 60-degree angles, and half of 60 is 30, so you're gonna get your 30s and your 60s. That's where the 30, 60, 90 comes from. So what that means is that this altitude has to be 3 root 3, right? Short leg multiplied by root 3 is 3 root 3. And they want to know um, the approximate area of the dark region. So the triangle itself we could find now, right? The area of the triangle is going to be the base, which is 6 times the height, which we now know is 3 root 3 divided by 2. So 18 divided by 2 is 9. So 9 root 3 is the area of the entire triangle. But now we need to find the area of the circle and subtract that out. And I don't know that unless I know the radius. Now, if you really paid attention first semester, then you would have remembered that when the three medians of a triangle intersect at a point of concurrency, they create what's called a centroid. And the centroids divide themselves into a 2-to-3 ratio. So what that means is if the entire centroid is 3 root 3, that the longer part would be 2 pieces of that, and the short part would be 1 piece of that. Okay, so that's one way you could kind of work through this, is by knowing that the radius has to be root 3, just like that. But that would have been a lot harder to remember that from that long ago. So instead, why don't we think about this? When I drew my second median there, I actually created another 30, 60, 90 triangle that was even smaller than the first one. See, there's the 30, and remember, we're still perpendicular with these medians because of the equilateral triangle. So this is 90. So that means that this has to be another 60 right here. Now remember, this was 3, and I should just be able to divide by 3 by root 3 to get from the long leg to the short leg. And if you divide 3 by root 3, which has to be rationalized, you do just get root 3. So pi root 3 squared is just 3 pi. And so 9 root 3 minus 3 pi would be the exact answer of the dark shaded region. And if you approximate that, it turns out to be like 6.15-ish, I think, 6.15 in that vicinity. But it said to round off to the nearest integer, and so you just said you just went with 6 is what you did in the end. So yeah, not an easy problem, but that's why it was a bonus. And I did have one person that got 6, and a lot of people were up in the 20s, and their answers were kind of a little bit all over. So hopefully this video gave you a couple things that maybe you were tripped up on previously, and now maybe you won't miss a similar question on the final, but you can certainly let me know. Um, if there's something you're still confused by, I cannot help you unless you let me know. Take care.